Hello, and this time Boolean Algebra Level 2. Problems get a little bit more complicated. This one, right, we need to express not C and not D in terms of NOR gates. Well, that means we're going to have to turn this AND into an OR. So the obvious first step there is to apply De Morgan's theorem. Let's try that. Not C and not D. Apply De Morgan's theorem to that, and that would give us not C or D. But that is a NOR gate. So we've finished. That's all we need to do. Just have to write that in the not notation with exclamation marks. Not C or D. Done. Next. Express this in terms of OR gates and inverters only. Okay, a little bit more complicated, that one. But once again, we have an expression here. And there's a AND gate there. And we're being asked to express this in terms of OR gates and inverters, so that AND gate has got to go. And we can convert AND gates into OR gates using De Morgan's theorem. And De Morgan's theorem here would be, well, it's just another not, and then that would be not n, or, and then not of not q, which would just be q or p. Those two nots here will cancel each other out, so I would just end up with not n or q or p. If I express this like this, then this is one inverter and one OR gate, and the output of this OR gate would feed another OR gate. If I were to write this out in terms of a circuit, I would end up with N going through an inverter to form not N there, that going through an OR gate with Q, and that would produce not N or Q there. And if I take that and put it into another OR gate with P, I would end up with not N or Q or P. And I've done this just with OR gates and inverters. So that should work. Let's try it. Not N or Q or P. Great. You don't actually need the brackets in there. As long as you could put brackets in there to make it in terms of a 2-input OR gate and an inverter, that would be fine. Next. Okay, here we've got to take the OR gate and convert this into an AND gate, because we can only use AND gates and inverters in this expression. So we've got not Q or not R and P. And we can convert this OR to an AND using De Morgan's theorem. And that would just give us that. Well, we take this expression here and take the inverse of that, and that's just Q. We take this expression and take the inverse of that, and that's just not R and P. We take this OR gate and convert it to an AND, and we take the inverse of the whole result. And then we've got this inverse up the top here that comes down there. These two inverses cancel each other out, so that just equals Q and not R and P, which has only got inverters and AND gates in it, so that should do. Let's try it. Q, not R, P. You don't have to put in the AND gates. If you just write two variables next to each other, it's assumed that you mean AND. Fine. See if there's another different type of one we can do. Done one like that. Apply De Morgan's theorem and simplify. Well, it might be easier to simplify that one first, because both of those sets of two knots cancel each other out. Not is the same thing as the thing. So here we've actually got P and N. That's it. Apply De Morgan's theorem to P and N, and you get not P, or not N. Express that in terms of the exclamation mark notation, and that's not P and not N. Just try one more. An evaluate one. This is an evaluate one with 3 variables in it. And if we just substitute in those values, that would be not of t, which is 0, plus not of open brackets, not v, which is also 0, plus u is 1, not of 1. And it's just a case of going through this. Right, well, not 0 is 1, and not 1 is just 1, so that would be equal to not of 0 and not of 1 plus 1. Well, 1 or 1 is just 1. Not 1 is 0. So that gives us not of 0 or 0. And 0 or 0 is 0. So that's just not of 0, which is just 1. Answer 1. The thing about these ones, normally if you get a question wrong, then your available mark halves. So if the timer had counted down to, say, 60%, and you get it wrong first time, but right second time, you might get 30%. But obviously on things like this, you're going to get it right second time, so you only get one chance. I think that's all you need to know about level 2. Good luck.